In this problem, we are given v of t is equal to 53 times cosine of 1000 times t plus 73 degrees, and this is in volts. We need to find the frequency in hertz for this voltage, find the RMS value of this voltage, and find the voltage Vt at 2 milliseconds. We're going to use these formulas right here. They can also be found in the notes, which are linked in the description below. And so we are going to start this out. The second problem should be B, but we're going to start with A. And A is to find the frequency in hertz for this voltage. Now, if we break this up, if we make it kind of look like this form right here, we know that our omega is going to be this 1000 right here. And we know that our phase angle is right here, which is this 73 degrees. So to start solving for our frequency, we don't know the period, so we're going to have to use the angular frequency formula. And this is that W is equal to 2 pi times our F. Well, we know our omega is 1000, so we can just plug this in as 1000 is equal to 2 pi times frequency, and then calculate this. And after we do that, we're going to get approximately 159.16. This is the answer for the first part. Now we are going to look at part B, where we need to find the RMS value of the voltage. For this, we are going to use this formula right here. We have that our Vrms is equal to Vp over 1/2. Our Vp can also be called our V of m. And our V of m right here is going to be this value. V of m is always whatever is in front of our cosine. And after we plug this into a calculator, we're going to get that our Vrms is approximately equal to 37.5, and this is our Vrms. Next, we need to find the voltage at t is equal to 2 milliseconds. All we need to do is look back at our original equation and plug in our 2. We're going to substitute 10 to the negative cubed for the m in milli, because that's what milli is. And we also need to change our degrees into radians, because we can only either work with degrees or radians. For this, I'm going to switch it into radians. So I'm going to multiply this by pi over 180 degrees to get rid of the degrees, and then it'll be in radians. When we plug this into our calculator, it's important to remember to switch your mode to radians if you're in degrees, and vice versa. And if we correctly plug all of that into a calculator, we're going to get that our V of t is equal to 2 milliseconds is equivalent to negative 52.5 volts. And that is how you would go about doing this problem. If you want more introduction to circuit analysis, there's a playlist and notes for the course in the description below.